hello everybody, and thanks for having me. I'm here to talk about Templ, which is an open source project that I build. It's a way of building front ends in the Go programming language. So I guess why would you want to do server-side rendered stuff in Go? Well, I work on a lot of commercial stuff, mostly retail bits and pieces, high volume, like insurance sales, those kinds of things. And you tend to need like static pages for search engine optimization. I also work on some government things, and in the UK, there's a design sort of set of guidelines called GDS, which talks about making sure that your applications run without JavaScript running on the client side. That's because in some cases, it might be virus scanners that disable it. It may be network issues. There may be things that are outside of a user's control that prevent them from using script. So there's a few reasons why you might want to have a fairly traditional web app. You might also just not have the skills in your team. You've got a Go back end, and you want to do a little bit of front end, and just enough to keep your application going. So there might be a sort of learning curve argument as well. And also, if you're rendering something on the screen, you're going to be waiting for that API anyway. Are you really getting much benefit from firing up an SPA just so that you can display like a loading animation? Maybe not. So if you're going to do this in Go, what do you actually need? Some sort of templating library that feels familiar, something that's kind of easy to pick up and use. Good developer experience, something that sort of doesn't make you hate your life when you're using it, and a bit of an ecosystem around it so that it's not just you're not hand cranking everything yourself. So Go ships with the standard library, so the usual response is, why would you not just use the stuff that's built in? And the reason is that it fails in weird ways. So if you're not familiar with the Go templating system, this one here fails when you start your program, because you can't call arbitrary functions in a Go template. You have to pass in a function map, and then so you'd have to pass in toUpper into your function map in order to use it. So that's a significant source of friction. And this one here fails at runtime when you try and render the template. And that's because there's no price field, but because Go's built-in templates are only rendered at sort of execution time, you can't see that until you try it out later. So it fails in front of your customers, which is possibly the worst time for it to happen. And the developer experience isn't really what you'd expect. If you've ever done React, it doesn't feel like good. Yeah, so if I'm old enough to have done the sort of rounded corners pixel tricks and all the rest of it, and old enough to have used Razor pages when they came out in 2011. And that had all the kind of mod cons, IntelliSense, and like the auto-completion, syntax highlighting back in 2011, right? So if I'm going to say to a team, hey, we're going to use this Go templating, but it's kind of like stuff that like you did in 1998, it's not going to feel great to people. And if you use JSX, then again, you'll have been really familiar with that kind of tooling, that kind of style. And this is, again, a transpile thing. You write your TSX or JSX, and it gets turned into JavaScript and executed. So if you're familiar with JSX, and Templ isn't going to look like a million miles away. Originally, rather than trying to build something new, what I tried to do is work with the existing tools that were there. And try and add auto-completion and all the good stuff into it. But the design of the tools that were available at the time, they weren't really built around this concept of type safety from the get-go, and didn't have sort of annotations. So I ended up having to build something to sort of scratch the itch, if you will. So what you've got here is this Templ code here gets compiled into Go code and bundled as part of your application. You can define a Templ component by writing this Templ syntax here with parameters and interpolate variables into the result. You can then use that, compose those components together with this @ syntax, and you can insert sort of standard functions and normal controls flow into your HTML components. And then you can render them to standard out, so you can get data, pass it into your components, and then render it out to a target writer. So the kind of typical workflow then is create a new Go project with this Go mod in it, install the Templ command line tool, create a Templ file, generate Go from that template, which takes a few milliseconds, and then run it. And you get out a Go file that looks a bit like this. So it's really straightforward. All it's doing is writing straight to that I/O writer. And that means that the result of it is pretty fast, right? Who cares about a few nanoseconds here or there? But, you shouldn't have any concerns about the performance of that. But the benefit of the compilation step is that you get compile time errors, right? So if you're trying to use a field that doesn't exist, it's going to break before it gets to your customers, not in front of your customers. But who wants to wait for that, right? Who wants to wait for the compilation? Obviously, not me. I want to have a language server. I want to have red squiggly underlines in my editor. So I built a language server, an LSP, a language server protocol server that ships with Templ, and a VS Code extension to go along with it. VS Code is the most popular tool used by Go programmers to build Go. But there's also NeoVim, because we're not animals. And there's even a Golang plugin as well, which is a little bit less advanced because JetBrains only recently added the language server protocol support into the tooling. But yeah, there's all the kind of editor support that you might expect. In the background, the reason that I'm able to do that as one person with another co-maintainer is because I piggyback on top of the rest of the Go tooling. So Go already ships with a language server protocol. So what I do is pass the Templ file and then remap the positions of the Go code within it to the actual generated Go code, pass the information through to Go please, and then I can map it all the way back. And so that means that you get pretty much all of the features of the Go language server, just in your templating language. Recent innovation is live reload as well. So we're compiling this stuff, right? And when you compile a Go program, you make a binary and then you run that binary. So if you make changes to your template, surely you would have to recompile your Go binary and restart your process, restart your web server, right? Not in this case. If you go into watch mode in Templ, it watches all the files in the background, and it generates code in a developer mode that reads all of the HTML strings from a file on disk. So that means you can reload in the browser automatically without having to recompile your application for those. It's only if you change your Go code within your templates that it needs to do the restart. And this process here handles it. There's also a proxy thing here, so it introduces a server-sent event to reload the browser, because who can be bothered to press Control-R? Life's too short. So the center of Templ is this concept of the Templ.component interface. So in Go, when you define an interface, you can implement that interface implicitly. So anything that has a render function on it that takes a context and a writer and returns an error, anything that has that function signature automatically implements Templ component, and that makes it really useful for plugging in other components of the ecosystem, which we'll see in a second. So this thing here, the Templ component, produces some code that implements the Templ.component interface. But you can also implement it in code. So you can, here I've defined a button. It's got a field on it called text. And then I can implement the render function. Now, obviously, you're on your own here in terms of content escaping. So any kind of cross-site scripting kind of problems and stuff, that's up to you to solve in a code-only component. In a normal Templ component, all of the content is auto-escaped for you. And then, yeah, you can render out your code component, and you can compose that like you would any other Templ component. You can also compress that down into a sort of more anonymous function. So if you don't want to define a type, you can define this Templ component func, and that just turns a function into something that implements the interface. As you might expect, you can compose templates together. So you can define a left, middle, and a right, and then show them all together in one go. The Templ component interface takes this writer, this io.writer, and in the Go programming language, pretty much there's lots of things that implement that io writer interface. One of them is files, and the other one is HTTP responses. So if you want to sort of use Templ to generate static files, you can create a file on disk and then just call the render function on the component. And this is one of the kind of first use cases that I had for Templ, is working at an insurance company, making really complicated insurance documentation for tens of thousands of people every day. And so you want to have there are tens of thousands of documents every day. And these documents contain so many fields. And any kind of issues with the template where you weren't seeing the right data could be sort of reportable to, what's the right word, the Financial Conduct Authority and stuff. So we were really careful on getting the documentation right. And so using Templ and having these extra compile time checks was really helpful for us. Of course, you can use it in HTTP server, right? So here's the longhand version of it. You call your component, so get this Templ.component, and then Templ ships with a thing called Templ.handler, which does a few niceties around HTTP responses, making sure that if the template rendering fails for some reason, that it returns the correct status code and stuff like that. But essentially, it turns your Templ component into a HTTP handler in Go. So you can boil that down to a single line there. So if you've got like a Templ component, it doesn't take much effort to turn that into a web page. And obviously, you'd probably want to host some static content because we're here at HTMX Conf, I guess, so you probably want to include HTMX. In the Docker side of things, you can host Templ. It's just because you're just building a Go binary, you can host it anywhere that you can host Go, right? There's no special thing about this thing. So you can use Docker, and the usual way is like a multi-stage build, where you have one stage that does the build, so it has like the compiler and all the other stuff, and then a runtime image. And the runtime image is slimmed down, so it doesn't have any of the tools and stuff. So that's really useful for reducing the number of vulnerabilities that get discovered in images over time when you ship them to your cloud provider. But I'm tight. I don't like to spend money, so I like to use Lambda for things that are sort of hobbies or smaller things, or in fact for commercial projects as well. And so you can, typically with Lambda, you have to implement this thing called a Lambda handler, but Go has an adapter that you can use. So you can create a standard HTTP handler out of a Templ component, and then you can use a Lambda adapter just to convert that into a Lambda function handler. And the performance of Go on Lambda is really excellent, and you can use the ARM64 ones to save a little bit more on your CPU costs as well. Static content with Lambda is a bit of a pain because typically it's quite expensive to do large responses with Lambda. So typically people introduce like a CloudFront and route some stuff to an S3 bucket and stuff. So it gets a bit complicated. But there's an example repo there's an example in the Templ repo full with CDK and all the rest of it that you need to do that. So what does it look like with HTMX? I hear you all ask. Well, it's in the Go world, we don't have anything so really opinionated, right, as Rails, right? Go is quite resistant to that as a community. So you're probably going to see some things that you think, well, that's a lot of code, right? But it's very simple code, and it's very easy to understand. And I think that's one of the things that I really enjoy about Go is that you can get somebody who's never touched it before, and they feel pretty familiar with it, and they're using it effectively in a couple of weeks, and it's easy to learn. In sharp contrast, I guess, to some of the onboarding experiences I've had where you're bringing in lots of developers who are learning TypeScript, and they're coming from other languages, and it's such a flexible language that everybody writes it in a sort of different way that sort of represents their background. So cohesion as a team can be quite challenging. So here's a view in Templ. We're receiving a list of or slice, it's called in Go, of users. And we're going to put a link in to add. And because I'm lazy, I've put in the HX boost there. And that's a feature of HTMX that turns what would be a full page refresh of that page into a partial refresh of just the active content. If there's no users, print new users, or just display the users, and that's just iterating for a normal for loop and displaying the users out there. So to implement a HTTP handler in Go, you have to implement this serve HTTP function on your code. So it's like part of the HTTP handler interface. So typically I divide it up into a get and post or whatever verbs I'm using. So the get request is all it's doing is grabbing some data from the database and shoving it into the template and rendering the results. Very straightforward in terms of implementation. The add page is a little bit more complicated because we're going to have to receive some form data from the client side, right? So usual practice of that would be to create a model to hold that data that you're going to receive from the form post. And you might apply some validation to it. So if you're creating a new item, you might want to sort of do some validation and say, well, this is an invalid email address or something. So let's have some functions on it that provide validation. And then here's our add view. It's got a form. We're using the HX boost again. It's going to post towards that users/add endpoint. And then we can start implementing straightforward, labels and fields and stuff like that. And if you start doing this a lot, I'll show in a couple of slides how to build up your own component libraries and stuff like that. Because obviously this is kind of a bit boilerplatey. You might get a bit frustrated with that over time. So then we're just rendering out the forms, and then if there's an error, displaying it to the user, or just displaying the validation messages. And again, we're making use of this sort of the ability to compose Templ components into sections with this validation messages. The handler is a little bit more complicated for add. We've got two verbs, get and post. So in the case of get, we're just displaying the form and saying, okay, just display the initial, don't have any validation messages because the form isn't dirty yet. And then we've got this display function, which is, again, like you've seen before, we're calling this handler, which just takes the view and renders it out for you. The post is a bit more complicated because we've got to pass the form that we've just received in from the client. And then we can use Gorilla's schema library to map the fields that we got from the HTTP form post onto the struct, which if you're familiar with classes from other programming languages, like you're just copying the data from the post straight into the form. At that point, you can run the validation functions and kick the user back out to show the validation and exit early. Or if there's no validation errors, you can try and save the entity to the database. And if it fails, because your database is overloaded, you can display an error. And then if everything's okay, redirect the user back. So pretty traditional kind of MVC style thing with a little bit of HTMX magic to make it not feel terrible. And that's a kind of low-cost way of building things. Now, React isn't going anywhere though, right? Like, it's useful. There are lots of like client-side components that you want. I think we saw some great examples of things like graphs, right? Those are really useful. And so you can interact with it. You can create React components, that's no problem, and then attach them into your client, pass data from your server side into the client side. So all you want to do is kind of attach things. So here's a basic component, and here's a function where you pass an element and it mounts that React component in. But using the Alpine style thing of you can put JSON into attributes of your elements and then load them into your React side. And so that's a way for you to pass data in a fairly straightforward way from your server side into React components that might be running on the client side without having to build like APIs and start fetching back and forth and adding that extra complexity. And you can build that with AS Build, which is really fast, so you don't get into sort of massive build cycles. And so, yeah, then the passing data to React bit inside Templ is straightforward. You create a Templ component, which has this data dash, whatever it is, attribute on it. And then you can grab that information and mount the component by looking at the closest div element and mounting that in. So there's a way for you to, you're not locked in. If you start going down this route of using Templ, you're not like, oh God, I'll never get out of this thing. You can plug in like other things in the ecosystem. And that means other Go templating libraries as well. So if you want to use something from the standard library, there's like this one here, there's a Templ function that turns that straight into a Templ component. So you can pick up the standard library. And there's this other thing called components, which takes a totally different approach. Instead of creating a weird DSL like I did, they just did it in Go code, which is probably more sensible. But it looks a little bit strange, but you can convert that into a Templ component and render it and use it and compose it just like everything else. So again, you can make use of the wider ecosystem. And if you want to build your own component libraries, it's just a standard Go package. So it's the same process for sharing like any Go code that you want to share with somebody else. There's nothing special about Templ components. You can just create them. So you create a new Git repo, create a module inside it, import Templ, write your component. Now in Go, if you want to expose something as public, you just start the function name with a capital letter. And so if you create something like Templ hello, generate the file, commit it, and push it, that's it. You've created a reusable component library that's available on the internet. And then you can import it with a single line there. You import the file, get it, and you can then use it within your own projects as well. So it's relatively straightforward to build these things and share them around. And people have started, like people I don't know, have started building up component libraries like this one, GoPress, is going to be launched soon. It looks pretty impressive. And there's some other kind of components that people are building. So I'm hoping to see some interesting components get developed over time. So a couple of things that we've added recently to Templ is a playground. So this runs in WebAssembly in the browser. So you can try out Templ without actually having Go installed on your computer. If that offends you in some way, you can try that. Also added this thing called rendering once. So sometimes you want something to only be rendered once to the page, like each HTTP request. So there's this thing called a once handle, and then you can wrap children around in this once handle. So if you want to sort of do something like render a script to the screen to the page, you can do it, and it only gets rendered once, even though you're using the component multiple times. So that's a way for you to sort of load in dependencies and bits and pieces. And then what am I working on? Automatic Go imports. So here I've used FMT, but it hasn't brought it in. That's really annoying, because when you press save, it'd be really helpful if it just brought it in automatically. So that's coming soon. And people have asked for HTML LSP. So this is one of the things that I didn't know what I was missing out on, because I've never seen this, right? But it turns out that a lot of people, if they use VS Code, are used to having this HTML auto completion inside, but you don't actually get it in JSX, and so I'd never actually seen it. So I'm working on a way of mapping through to other language service providers, LSPs, sorry, language service protocols, and bringing back the results from them so that you can kind of enrich it, so you can use things like the Tailwind LSP and other things inside, like all together at once. And then another thing I'm working on is streaming responses. I have a good POC of this. So one of the nice things about Go is its ability to do multi-threaded workloads. And one of the ways you can do it is with this thing called a channel, which is a bit like an in-memory queue. So you can iterate over a channel. So you might do something like run a Go routine in the background to fetch some data from the database and then stream it back through to your template. So you can kind of start rendering out some HTML and then in the loop flush out parts of your response back to the browser. So that'll be coming soon. So yeah, like why should you bother doing this? Well, Project Health, thanks to Prime and Carson, the project's had a little bit of attention, I think I would say. And so thanks for that. And so it's maintained by me and a friend of mine, Joe. But I think stars are cool and everything, but contributors is what really matters. I think, for the long-term health. So we've got like over 100 contributors now to the project, which I think is good. I feel like it's sustainable, and I'm going to try and make sure that it doesn't become unsustainable as a project. Like it's got to be like it's no good if I start hating doing it, right? Or my wife says, "Please stop." So yeah, that's what's going on with it. There's an online community. There's docs at templ.guide if you're interested in it. The Go community has a Slack channel. There's a Templ channel in there if you want to ask questions and stuff like that, or just bring up on GitHub discussions. And obviously, there's people on YouTube who make stuff with it, and they've got like examples of doing stuff, and there's Reddit as well. People talk about Templ on Reddit. It's quite strange the first time it happened. It's like, oh, people are talking about this, and it's like, I don't know them. But so that's it, isn't it? I think, I'm not sure how we are for time, actually. Do we have time for questions? If not, I'll have to see you at the pub. Oh, yeah, we'll say one question. Has anyone got a question? Maybe not. A question over there. Does it have a formatter? Yes, it does. When you, like, I'm pedantic about it. I wanted it to be as batteries included. I'm trying to keep it so that there's no config file either, because that just increases the space of the weird configuration problems that could happen. Yeah. So the question was, does it have a formatter? Yes, it does have a formatter. All right. I think that's it then, folks. Thanks for having me.